Okay, I've gone ahead, I've redrawn the triangle at the bottom, and I've put all the calculations on the board. I'm starting to think I should have got a bigger whiteboard, but we'll take it slow. So in black, I have numbers circled. 1, 2, 3, 4, 5, and 6. That's the order in which I solved this question. But it is not the order in which you had to solve this question. For instance, the last step I did was 6. I could have made that my first step and then adjusted the accuracy of my triangle to that angle. So I know, looking at my triangle now that I just drew roughly, it's not accurate to 65.8 degrees. I would have a much steeper angle. Nevertheless, it's not pertinent to the question, but if you're particular about the accuracy, you could have done step 6 first and then drawn your triangle. So let's go back. Step 1 was the first information the question gave us. 600 volt motor draws 50 amps. It's your circuit that's your circuit voltage, and if I put an amp probe around the wires feeding that motor, it would draw 50 amps. It's not necessarily what the motor is rated at, 50 amps, but it's what it's going to draw after losses. Now, this power factor is very poor, 41%. That's a lot of wasted power. We would need a large capacitor in this circuit to correct that. But this is the variables we've been given. So my VA is going to equal 600 volts times the 50 amps. Those are the two first numbers I got. I have 30,000 VA. So you can see that stayed in green throughout the process of this question. I need that 30,000 VA for step 2. So step 2, power equals the 30,000 VA times now the decimal of the power factor, 0.41. Because I know my watts are going to be smaller, so I got to multiply by a decimal. So I have 12,300 watts. So I kept that in purple. I've now answered A and B of the question. For my VARs, I'm just straight up using Pythagorean theorem. So VARs equals my VA squared minus my watt squared. I actually see now I forgot to square my wattage. So VARs equals 27,362.6. I'm going to need that number as well to solve E. So go to step 4. Voltage across the resistor is equal to the power over the current. Remember, it's a series circuit. Current is the same across all the individual components of the circuit. So I didn't have to come up with a new current. They give it to me. So we're just using Ohm's law. So ER equals P over I, or 12,300 watts, divided by my 50 amps. I have 246 voltage drop across the resistor, the resistive portion of my circuit. Step 5, EX, so the voltage of X. Now, we had no capacitive component to this circuit, so it's just the inductor. So that was my VARs. So now, again, it's Ohm's law, but it's isolating that portion of the triangle to calculate the voltage drop across that portion of the triangle. So EX equals my VARs divided by the same current, because it's a series circuit. I get a 547.3 voltage drop across the inductive portion of the circuit. And then we go to step 6. This is just the steps, the order of the steps I decided. So my angle is equal to the cos inverted of the decimal of the power factor, so 0.41. So I have an angle of 65.8 degrees. So this was your series circuit power factor question. Shortly, in a couple videos from now, we're going to look at how we could correct this circuit by adding a capacitor and what that would look like.